across the fields of Europe is a new force to be reckoned with, the high-speed train. Capable of reaching speeds of up to 205 miles an hour, these things are like jets on wheels, and they're really giving the aviation industry a run for its money, slashing journey times and bringing the cities of Europe closer together. Building a train system that runs at a quarter of the speed of sound is a tremendous challenge. So, how do they do it? It's 5 a.m. at the Rummelsburg train depot in Berlin, Germany, and driver Dieter Konatka is boarding his train to begin the early morning shift. Dieter is on his way to collect passengers from Berlin Gesundbrunnen station, where he'll begin a 100-mile journey to Leipzig. If he were driving a conventional train, the journey would likely take over 2 hours. But this is one of the new ICET high-speed trains, which has reduced the journey time by 50 minutes to 1 hour and 26 minutes.
It's definitely a thrilling feeling to be driving 10,000 horsepower.
10.000 PS oder auch manchmal mehr.
The German high-speed network now has over 200 high-speed trains whizzing around on over 3,720 miles of track, with over 620 miles built in the last 10 years. There are 5 types of ICE trains, and the largest has up to 16 cars capable of carrying 916 passengers at the speed of a Formula One racing car. Creating these monsters has meant completely rethinking the design of many key components, and one of the first problems the designers had to tackle was how to make them light enough. Conventional trains are made from steel, which is way too heavy for a high-speed design. To begin with, a steel train takes a while to get up to speed. Then once going full tilt, its momentum would make it nearly impossible to stop, as well as cause it to derail when going around corners. To find out how they solved these problems, we've come to the Siemens train factory in Krefeld-Uerdingen. This is where they build the enormous metal cars on the latest high-speed trains. As they move through the production process, these cars are transported from one workshop to the next using a giant remote-control cargo transporter. In fact, these huge cars aren't as heavy as they look. That's because instead of being made from steel, they're made from aluminum, the same material used to build aircraft. The result? These new lightweight cars weigh just 55 tons, 30% less than if they were built from steel. But using aluminum brings its own problems. While it melts at the relatively low temperature of 1,220 degrees Fahrenheit, it conducts heat far more efficiently than steel. That means you need one incredible arc welder to join the stuff together. Using 10,000 watts of electric current, this giant arc welding machine generates heat at around 5,432 degrees Fahrenheit, fusing the metal sheets. It can even give the workers sunburn. So when manual welders like Vahenten Wagner apply the finishing touches, they have to make sure they're well protected.
The cream is essential to protect me from harmful rays.
The next challenge for the designers was how to power the train. The conventional system of putting the engine at the front is extremely inefficient. When the only powered wheels touching the tracks are at the front, it's slow to accelerate and struggles to climb hills. What's more, with the engine taking up most of the front car, space that could be used for passengers is wasted. So the engineers came up with an ingenious solution. For the ICE3, instead of one massive locomotive at the front, they installed 16 smaller electric engines under the floor. Powered by special high-voltage overhead cables, these multiple engines mean that every second car has 4 powered axles. As a result, the ICE3 can climb a gradient without losing speed and can even cross borders and change line voltage without stopping. What's more, the unique engine system means there's 20% more free space than in a conventional 8-car train. Now, having designed a train capable of speeds of up to 205 miles per hour, you need some very special rails to run it on. So here, in the heart of the Austrian Alps, Verst Alpine has built one of the largest foundries in the world. Conventional rails have a lot of joints. To reduce the number of joints, the rails they make here are a staggering 395 feet long. That's as long as a football field. Unlike standard tracks, these high-speed rails are then welded together on site to make sure there are no bumps where the tracks join. Next, the only way the train can hit its top speed of 205 miles per hour is to travel in a perfectly straight line. Which is fine when you're going through a flat, empty field, but not so good when there's a huge mountain in your way. Then, you've only got two options: go around it or go through it. Coming up, how do they get a high-speed train around mountains without slowing it down? Find out next on How Do They